Hello, everybody. Welcome to World Virtual Tours, to this new project, the Academy courses here in World Virtual Tours. I am glad to be here. It's a pleasure for me always to be your guide and today your teacher. Let's say, right, in this new event we have. We're going to talk about the Mesoamerican mathematics, geometry, and astronomy. Hello to our friends. Let me know where are you connected from today. We have Astrid from Florida, and also Andy in Florida too, and our friends in Minnesota. Okay, so let me know where are you connected from. Also from our part of the world. We have friends in Arizona, and let me explain a bit. Okay, this will be a course that will have 4 different sessions. This is the first one, and it will be mostly about the Mesoamerican and the pre-Columbian civilizations mathematics. Okay, I hope you can learn and we can learn together with all this project. Okay, hello, thank you, James, thank you, Mason, thank you, Osher, John, Teresa, Jackie, and Annette and Rosa. Okay, so welcome to all the students today, also our friends in Austin, Wisconsin, Mar in Caracas, Ireland, Nashville, Mar soon to be in Mexico City, Estonia, and San Francisco. Okay, so let me know before beginning if you know something about the mathematics of the pre-Columbian civilizations of the Americas, mainly in the area that we know as Mesoamerica. We're going to speak much about the Aztecs, the Mayans. We have other civilizations, of course, in the continents, ancient civilizations like the Incas, but those were not part of Mesoamerica. That's why we are not including that in this course, but we'll have anyways many things to see and to learn about this. Okay, so let's begin with the course today. Let's just wait 1 more minute for all the attendants to arrive. It's earlier than my regular tours. And as we mentioned, I know some, sorry, let me read. I should mention that some I learned in math class, but not very much in this type of math story. Love math, one of my favorite subjects. Yeah, okay, maybe you have heard about the Mayan astronomy, about the Mayan number 0, and so. And so let's begin now, guys, okay? I just want to remind you quickly that these courses will be free, but we will have here the opportunity to make a donation if you want to leave a tip in the first link. If you click on it, you will have the opportunity to tip if you like these courses, if you learn. And in the second one, you can book the next sessions. That will be 4 in total, mainly this same day and this weekday and this same time. Okay, so let's begin, guys. I will close the chat for you to be more comfortable during this tour, and it will be open again at the end because we will have time for questions and answers. So let's begin, guys. This is the contents that we will have in the course. We will start speaking about the ethnomathematics, one branch of the, and it's a cross, right, between the anthropology and the mathematics. Is how people study how the ancient mathematics were. So we're not going to focus much on perfect and to learn perfectly the system of the mathematics of these ancient civilizations, but we will understand how they taught, and also we will try to understand all the systems and how they became important and how they use these systems for many other applications. We will start in this class, we will learn about the numerical systems, all the origin, all the anthropology around the numerical systems in Mesoamerica. In the second session, we will speak about the astronomy. Okay, we will understand how they develop the calendars, how they also study the movements of the stars, the planets, the sun, and the moon in the sky. And so they could develop other system, a bit more complex of mathematics and especially geometry. In the third session, we will speak about the geometry, mainly for the architecture, how they use all this knowledge for develop big cities to make these cities and the layout of these that are really connected to the astronomy and to the movement of stars and all the sky map, let's say. Also, in this third session about the geometry, we will see the patterns of operation and layout of other buildings, because let's say in this case here, we have a decoration, a very famous decoration in Mitla, in the city of Mitla, in Oaxaca, part of the Mixtec civilization. And as we can see and we can notice, these patterns are actually fractal. Okay, so in the third session, we will discuss and we will learn about this. And in the fourth session, we will learn about how they use the math in the daily life, like in trading, of course, the commercial system they had, the tributation system they had, and also the finances, the economy of the cities, and the accountants, how the accountants work, because they had accountants and they had documents of accountability in their cities. So this is all the content of the course. So let's begin with the first part. Let me first give an introduction, specifically speaking about the ethnomathematics, and so we can understand how the system has a logical reason to be like it is. Okay, so let's speak about the peopling of America. Okay, the population of America, it happened about 20,000 years ago, and according to the theory of the populated continent, they crossed from Asia, from the Bering Land, the glacial age. So Asia started arriving from nowadays Alaska, between this bridge of ice between Russia and Alaska, and they populated the continent. Let's consider that back in those days, most of these groups, they were not like a full known civilizations or cultures, but only groups that began to um, living together, but they were nomadic. Okay, so the population of America started 20,000 years back from the coast, mainly from the coast, from the overland routes. It took a bit more time because of the mountains and all that, but by the coast was always more easy. Also, there are versions, other theories mention that maybe some of the first populators arrived from Europe 24,000 years back. But the most accepted theory is the one that they came from Asia, at least in this part of the world. Nowadays, Canada, United States, Mexico, Guatemala, Belize, Costa Rica, Honduras, and other countries from Central America. Okay, as I mentioned, they were gatherers and hunters. That was the main activity they had, and even in these continents they found big animals, the super fauna like the mammoth, also different types, the grandfathers of the sloths. Horses existed in this continent, and also camels existed in these continents before the arrival of the first people. But let's consider that they migrated in the opposite direction during the glacial age, and that's why we have for many years the horses only existed in this other part of the world, in Asia and Europe, but not in this continent. But horses and camels are natural from the Americas. Most of these animals were extincted about 10,000 years ago, or around the year 10,000 before Christ, for being more right. Okay, so this is the Mesoamerican area under the Tropic of Cancer, an area that has no the strong changes in the temperatures during the different seasons in the year. Very well marked seasons more to the north of the Tropic of Cancer, with winter, autumn, spring, and summer well divided. But these lands over here are evergreen lands. Okay, so the sun is more or less always in the same position. The day lasts more or less the same hours of the day, and also the nights and the day are well equiparated, and even the duration, the last of the days, it is really steady during all the year, and also the rains and all that is something that we have here in this region, because I live in Mexico City, still in this region, the same weather during all the year. So it is a very good land for more civilizations to start to grow more and to choose this place to grow and develop a bit more. This is the Grand Volcano in Costa Rica. I normally in my tours only mention Mexico, but I take this opportunity to speak about other places where these civilizations had place, like in this case in Costa Rica. Okay, as you can notice, in Mesoamerica, we had many different civilizations, like the civilizations of the Gulf of Mexico, the Maya, and the center where the Aztecs existed, and also Oaxaca's here in the South Pacific. These four, the Gulf, the Maya, the Oaxaca, and the center, are the main that we are going to speak about their mathematics during this course. So with this occupation of the evergreen lands, we have the development of the agriculture around the year 5000 before Christ. These are part of the products that that are original from these lands, like the corn, the fungus that made the corn, that is also a good dish, the cocoa seeds that they used to drink, the cactus, of course, that is edible in many cases, or drinkable in other cases, like the agave plant. Also with corn, they made beverage and drinks, and so we have the avocado, in this case in guacamole. Okay, and these are squash flowers on top. Actually, they developed the corn during this the evolution and the domestication of the corn happened during these times, around 5,000 or 7,000 years ago. So they started the transition from hunter-gatherer societies to agricultural societies. And this is really important to understand the mathematics they developed. Okay, these two concepts of agricultural mathematics, believe it or not, and I will explain why, are strongly connected. Okay, but let's consider that with these developments of the agriculture in this part of the world, there is a growing concern about ensuring good harvests. Okay, so what they needed to do to ensure this harvest, well, they had two options, and many other civilizations in the world also considered these two options when they discovered or when they first used the agriculture. Let's consider these two options as the calculation of the seasons of the year to know when is the rainy season, the dry season, and so, or the worship for the natural forces, asking for them to rain. And so in the case of Mesoamerica, spoiler alert, it is the two together. Okay, they worshipped and they made calculations at the same time. So the more complex calculations began with the concern about ensuring good harvest in these lands, and of course keep living in a more safe way, living in bigger communities, not anymore in caves, developing more the architecture and so. Okay. So other information about Mesoamerica is that Mesoamerica comes from the Greek word mesos, that means middle or intermediate, and it denotes the location of these lands we're speaking about, okay? Between North America and Central America, it is called Mesoamerica, the middle of the Americas, okay? So let me continue with this. Okay, nowadays we know that we can make calculations, and we have fully studied the system of the movements of the planets, the rotation, translation, for all these things, all this natural phenomenon to happen. And even nowadays, we cannot predict exactly when it's going to rain or when it's going to be a volcanic eruption or an earthquake or a hurricane. But they started with this try, okay? Let's consider that they didn't know that we are floating in the space on a sphere, but they started trying to measure these movements about the elements they had in the sky and in land. So they developed calendars and measurement tools for this, and different techniques, and of course calculations for this. This is the Aztec calendar. About this we're going to speak a bit more in the second session. So all these different civilizations with this concern started to study these things. Okay, so this has been just the introduction to start studying the numbers and the actual systems that we are going to speak about today. These are some cities that could develop even more with these complex calculations. Chichen Itza in Yucatan, Monte Alban in Oaxaca. Many of these cities we have spoken about in the virtual tours I've been doing in this platform. Civilizations like, also, in this case, Monte Alban was home of the Zapotec. Chichen Itza was home of the Maya hybrid society with the Toltec. Teotihuacan, the origin of the Toltec civilization. And let's consider also about the time and space, how they consider the time and space during their existence, and in absence of more sophisticated system to understand the natural forces, perception were generated to explain this phenomenon too. Among the concepts that were explained in a more complex manner is the time. Okay, so let's remember that they mixed the concepts of the calculations they could do with the worship they needed to do in order for the universe to keep existing. So in this case, the time is the cyclical and orderly movement of the sun. The sun, in its apparent journey through the four directions of the cosmos, generates life. Thus, these complex societies begin to understand time as a succession of cyclical movements. This is very important because it's always a cycle. It's always finishing something but starting something new again, especially when we try to understand the worship they used to make. So each cycle brings a function or role and different energies for animal, plant, and animal life. And also each cycle, if it's well remembered how it was in the past, we can interpret the present and the future. So these are the four different points of the cosmos they considered it existed. Okay, let's remember, for them the universe or the planet was flat, and we had four main directions. So the number 4 is one of the main numbers that we are going to study, especially during the third session. Also, on top of us, we have 13 different skies, 13 different levels above us, okay? And underneath, we have the underworld with 9 different levels, 9 different worlds. Okay, so when we reach the lesson number 3, we will notice that this 13, 4, 9 is not a random thing. even when they use this also like calculation, they try to make a more complex calculation with the mix and the multiplication, for example, or division of these different numbers, okay? So we are going to understand how or why they use the number 13, the number 4, and the number 9. Part of this that we're going to explain in the next session is the Maya calendar wheel, measuring days, moon cycles, years, and full eras, okay? They had 20 natural days or 19 natural days with different months of, with the multiplication would be 260 and 365. And with all these calculations and the round of the wheel, they will calculate full eras. But I will explain more of the Maya calendar during the next session. So coming back to the explanation, they had 4 different directions in the universe. In many of the codex they made, they show this ideology. They had the 4 corners, 4 sides of the universe, and a center of everything. For make these calculations, to start counting 1 to one side or 1 to another, or 13 on top, or 9 under, underneath us, there was a center. Okay, so that center, it is part of the reasons on why they developed the number 0. Okay, there's always a base that we need to depart from to start counting. Okay, and also about the 0, I will speak today a bit later. Okay. Well, so remember the sun as part of the cyclical, with the cyclical movement, it marked the one of the main calculations they had, along with all the stars in the sky. We have materiality across spirituality. The sun, we could measure the movements, but also has a spiritual charge. And with this, astronomy across ritualism. Okay, so most of the rituals were born according to the movement of the stars. Okay, so let's speak about the first civilization in Mesoamerica that developed the mathematics. It is the Olmec civilization. So during the pre-classic cultural horizon around the year 1200 to the year 400, the Olmec culture emerged in Mesoamerica. Their cultural geographic area was located between the present-day states of Tabasco and Veracruz on the Gulf of Mexico coast. It is a cultural region known as the Gulf Coast region, home of the Olmec, the first more complex, bigger civilization in Latin America, in Mesoamerica, even before the Mayas. Okay, here we have a picture of La Venta, one of the archaeological sites of the Olmec civilization, also famous for these colossal heads. So the agriculture and the commerce were common practices yet for the Olmec. Let's consider that an approximate period of 2,500 years separates the Olmecs from the Aztecs, and they share ethno-mathematical aspects, despite there being no direct contact between them during their respective cultural peaks. It means that the Olmec inherited the knowledge to other cultures, like first the Maya and the Zapotec of Monte Alban and Oaxaca. We see the Maya in this blue line that lived in the same period of the Olmec, but the Aztecs arrived many, many centuries later, and anyways, they used more or less the same system that the Olmec developed. Actually, the famous Maya numbers, the famous Maya calculation, mostly sure, they were developed during the Olmec period. Also, let's consider that around the year 7,000 before Christ, it's here it says 5,000, but it would be 7,000. Have other the counting of different things having found in different caves, with this carving in caves in the northern part of Mexico, in many, and also in the coast of Mexico. But today we are not just to show the basic counts of these ancient first groups, but the more complex mathematics that especially the Olmec developed. Okay. So this is the earliest evidence of numerical inscriptions in Mesoamerica, the ones that the Olmec developed, and dates back to, we know, 14 centuries ago. Let's consider that the Olmecs faced annual flooding and hurricanes, changes in the ocean tides, which coastal communities often experience, and second period of rainfall at the end of the winter. These are part of the calculations they needed to have. So let's compare this with other civilization that developed complex mathematics like Mesopotamia. Mesopotamian economic system was based on agriculture, livestock, and trades, whereas the Olmecs never developed, for example, livestock, but engaged in fishing, which was not storable at the time. So they depended on the calculation of the tides, for example. So this situation compelled them to understand the changes in tides, and most importantly, the seasons of rainfalls and the hurricanes. Also, the Olmec were some of the first civilization that developed a writing system. These are still not the numbers, but different hieroglyphs for expressing other ideas. Found in stele. Of course, all the surviving documents we have is mostly thanks to the archaeological work, carving in stele, and just in rare cases, speaking from the Mayas onwards, it is in paper, in tree material, the surface of the tree. Okay, this is the timeline again of the pre-Columbian civilizations, and let's situate us in this part, in the connection between Olmec and the Maya, because the system that we are now going to study, it is mostly known by the Maya system. Okay, other cities that the Maya developed, like Copan, in this case in the current country of Honduras. So this is the system. These are the actual Maya numbers. Okay, this is one of the documents rescued with archaeology, and we see different things here in this board. Okay, of course, we are now going to explain this, but I want you to notice the different contents it has. We have columns with the numbers and the symbols we have here. We have geometric figures like these ovals. We have animal abstractions about here. And the next one, we see snakes. Okay, other snake over here. We see dots, of course, many dots. We see lines and human faces. Okay, in this case, the full person. But if you notice, here on top, there are other human faces too. Okay. Here again, we have the animal abstractions, the rabbits, this type of jaguar wolf, and persons, human beings, faces of human beings at the left, more geometrical figures, the ovals again, the dots and the lines. Okay, this is just to begin the recognition of these elements that we are going to use, and we are going to explain right now. Okay, this is the full system. Okay, this is the Maya system. So to represent to represent numbers from 1 to 19 in the Olmec and Maya numerical system, the concepts of additions and grouping were used, as can be seen in this figure. Okay, so we start with 1 dot, 2 dots from the number 2, 3 dots from the number 3, and 4 dots for the number 4. But in the case of the number 5, it will become a line. Okay, so every time you see a line, it is a number 5 representative or a group or 5, the number 5. Okay. After that, we need to start making additions. A bar that it's 5 with a dot on top will be the number 6. With 2 dots on top will be the number 7, and so, okay? So, as we can notice and imagine, reaching the number 10, we will have 2 bars. It is only the number 5 2 times. So for the number 11 will be the number 5 2 times, 5 plus 5 plus 1. Then for the number 12 will be 5 plus 5 plus 2, and so to the number 14. To the number 15, we'll have 3 bars, of course. It's only the number 5, but 3 times. 5 plus 5 plus 5, it is 15. 5 plus 5 plus 5 plus 1 dot, it will be the number 16, plus 2 dots, it will be the number 17, and so to the number 19. And the Mayans only could count to the number 19, and this is the end of the course today. Thank you, guys. Of course, it's only a joke, but how they represented the number 20 then. Okay, so we need to consider that now it is a bit more complex because it is about the position of the numbers, and we need to start with multiplications from this point. Okay, so let's consider that the numerical system developed by the Olmecs, which used these circles, dots, and bars, was a base 20 positional system. Again, and I will repeat this many times for this to be your main lesson today. It was a base 20 positional system, or vigesimal, and quantities were recorded vertically. That's why we have always columns. The first lower level was for units. The second for 20s. It means the number you put in the second position above the first one, you need to multiply that number, any of these first 19 numbers, by the number 20. And then in the first level, you need to multiply any of these numbers by 400 times, 8,000 times in the fourth level, and the fifth level would be 160,000 times, always with the multiplication of 20 by 20 times, 20 times, etc. Okay, so we are considering this as every space, every position of the numbers as the powers of 20. I will explain a bit more clear with some examples later, but I just want to see this first part of the system, right? And of course, we have the number 0 that is represented with the oval we mentioned before. That many interpretations are a seashell or a fist. Okay, so this is the basic Maya number. So let's watch some examples about it. Okay, as we mentioned, we have the columns, can be infinite columns to count to the infinite, but we're going to start with the power of 20 only 4 times, okay, to the number or the multiplications of 8,000. Okay, so if I put a dot right here, it is just the number 1, right? If I put a line here, it is the number 5, right? But if I put the dot right here, it will be the number 20. Okay, remember the system, it is based from 1 to 19, and it starts again with the 1, but in this case we need to multiply, make the multiplication in this second space, but 20 times. Okay, and this spot cannot be empty. If I want to write the number 20, this space cannot be empty. That's why they used the 0. Remember, the 0 is not only a thing for calculations, it's also a symbol of the, let's say, one original point where from all the rest depart. Okay, there's no empty. There's always kind of an energy trying to sustain all the other. Okay, so this is the number 20. Let's try and let me give you other examples. If I put a bar here, remember this bar is the number 5, but this is in the second position above the first one. We need to multiply this 5 20 times. Okay, so the number 5 20 times, it is 100. Okay, so a bar here, and we need to put the 0 again. Okay, this looks more like a a piece of bread instead of a seashell, but anyways. So this number we have here, and let's imagine it without all the squares around and the numbers around. This simple symbol, it is the number 100 in the Maya system. Okay, let me show you other examples. We have here other examples, right? We have, for example, the number 806. So it's 2 times the 400s. We always start the calculation from on top because we try to reach the biggest number we have with this multiplication without, of course, going further, surpass. So today, 800, we need 2 times the 400. That's why we have 2 dots in the third level. And the number 6, that can be represented with a bar and a dot, 5 plus 1, in the first position. And as in the second position, we need nothing. In this case, it's not nothing, it's the number 0. Okay, the Maya 0. Let's try with this other example under this first one. The number 2005. A bar, that is the number 5, in the third position, because we multiply this, we make the multiplication of this number 5 400 times. So we have the number 2000 already, then the 0, and then the number 5 as it is one time in the units space, in the units position. The number, I mean, yeah, this can be also used for calculate big numbers and the years and eras, no? Or at least express them. The number 10,145. To reach the closest 10,000, we have 8,000. So we have a dot, 1 time 8,000. 5 times 400, 7 times 20 for the 140, and 1 time the number 5. Okay, this representation here is the number 10,145. And this other bit bigger number, 16,125. 16,000, of course, is 8,000 2 times. then the 0, because we have only to reach 120, that is the number 20, 6 times. And the number 5 again as the bar. Okay, I hope everything is going is clear so far. At the end, we will make an activity together to better understand and practice this system. Okay, so we're speaking about the Maya in this case. Okay, all the area that's the Maya that was covered by the Maya kingdoms. It was not an empire, it was different kingdoms, but they shared this knowledge. And the language, for example. It's mainly jungle over here. And this is important to understand why they developed this system. It is, again, the study of the anthropology that allows us to understand why they use this. It's so easy to make the counts if we have rocks, sticks, and a bit rare, but not so because they are close to the coast, the seashells. Okay, so to make quick calculations on the ground of the jungle, you put 1 dot with 1 stick, and you have 1 number. On top of that, you have other dots, other group of dots and sticks, and you are conforming your columns, and you have make infinite numbers on the ground, right? The numbers here with the seashells. Or you can also draw easily on the ground of the jungle. Let's say this is not a language class, but these are the Maya numbers in the original language, at least in the current Yucatan Maya language. I will read them for you, just for this lesson to be more diverse and multidisciplinary, okay? The numbers in the Maya language are Jun, Ka, Osh, always with this emphasis, like rising the sounds, okay? Osh, number 3, Kan, Ho, Wak, Uk, Washak, Bolon, Lahun, Buluk, Kalahun, Oshlahun, Kanlahun, Holahun, Waklahun, Uklahun, Washaklahun, Bolonnahun, Hunk al. Okay, these are the 20, okay, numbers in the current Maya language of Yucatan. Okay, and the other symbols, okay, we have described the geometrical figures like the ovals. Now we know those are seashells, the dots, the lines, etc. But what about the faces? Well, we have only 19, a base of 19 numbers. We can represent these numbers also as faces in a more complex, sophisticated, used for the elites and the worship issues, right? So these are the faces that are equivalent for the most sophisticated writing to the 19 numbers. So if we use this guy on top of this other guy, we have a number following the same pattern of columns. It's with no sticks, I mean, no lines and dots, but it's a more beautiful representation of the numbers, right? Human faces. All of them, of course, with the previous names I also mentioned. Let's speak a bit more about the Maya number 0. Let's consider that the Mayan mathematics were also divine. The Maya 0 is a concept that synthesizes the deep relationship between their worldview and cosmogony with science, especially mathematics. The society was characterized by maintaining a close relationship between spirituality, art, and science. So in many cases, these faces were also faces of divine powers, for example. So this Maya conceived the 0 as this oval in a dialectical manner as the ends and the beginning of different levels of existence, in this case also for the calculations. we notice that the oval in the number 20 signified the end of counting in the place of units and the beginning in the 20s. Okay. We don't know if the Olmec also had this knowledge, but mostly for sure they had it. So this is these are other. Let's consider that in the ancient cultures, only two reached the use of the zero before the year 500. They were the Maya and Olmec, and also the Hindus about 1700 years back, more or less at the same time, or a bit later than the Maya. Okay, these are other representations of the number zero in the Maya, Olmec, and also further civilization like the Aztec. They use the same symbols for the numbers and the zero. In this case, we see the zero as the center of a flower. In some cases, the flower, it is incomplete because in some legends, the creative forces of the universe have not completed the universe yet. So the zero is not completed. We are only at the half. Okay, so we can see the numbers, in the numbers, a great philosophy too. Other measurements we can speak about. What about the length, the weight, the capacity, the volume, or the speed? Did they had the ability to make these calculations? In many cases, yeah, but not similar to the metric system we know nowadays. For the length, for example, as many other cultures, even the first Germans, for example, used the length with the anthropometric system. So we have different measurements here depending on your body. Okay, we have in this case the names with the Maya language. On a seal from the ankle to the knee, for example. Let's consider that the height of the people, those ethnicities. For male, it was about 160 centimeters. So they had more or less the average, or having the average height. They could make these calculations, and to ensure the measurements, they used the cords made with the agave, later also used in a more complex manner by the Mexica, by the Aztecs. We have here an Aztec codex that shows the mecatl, or agave cord, mecatl in the Nahuatl language, the Aztec language. Other part of the anthropometric system, it is the length of your two arms extended from one point to another, and it is Hunsab. And so, different anthropometric system, we will speak a bit more about this during the third part of the course, the third lesson, speaking about the geometry and the architecture they developed. To measure the volume, they had really, really specific measurements, okay? They had specific words with specific objects, and so they could calculate these different, the capacity of liquids, or how many pieces of metal or seeds of cocoa you had. For example, this is one of the most curious measurements they had, the Sempopoli. This is the amount of liquid that a cotton ball can absorb. The cotton is also natural from this region, and the quantity of water you can absorb with one ball of this, it is a measurement that was called the Sempopoli, and they use this for trading or for the measurement of different drinks or medicine and so. We have the testal, that is a measurement referring to the portion of corn dough you needed to make a tortilla. They developed the foods like the tortilla, these discs make with the corn dough. So the exact amounts of dough you needed, it is called the testal. And also, let's consider that They use it not only for corn, though, but for other different materials that can be calculated around the thing that you can put in your hand, no? The quantity you can put in your hand. Other measure for the volume was the Centla chipping wheelie that was equivalent to a drop of liquid, just a drop, okay? A drop of what? I mean, what liquids they used? They had no milk. Okay, we're back. We are back. Sorry so much, guys, for this little accident we had, but the signal is again on. Okay, so let's finish this course. And I was mentioning something about the ancient civilizations, right? Let me just take you to the point where we was, and let me. You can hear me well right now. Just type. You can type in the chat if you can hear me. Just please type yes if you can. Okay, thank you, Rosa. Sorry again, but let's finish this lesson today. Thank you so much, guys, and let's continue. Okay, so did they need to calculate the weight of different things, as we are in warrior and trading civilizations? Actually, thank you. Okay. Sorry about, so the cotton balls, right? The cotton balls. The cotton balls is the measure of the water that can be absorbed by a cotton ball. The testal is the measuring of the corn dough needed to make a tortilla, and the centla chip nili was equivalent to a drop of liquid. So these are the different measures of the water. Okay, so this speaking about the weight, they didn't have this really strong necessity of measuring weight. It is more a necessity of calculate small things, okay? How many fishes, or how many pieces of cocoa beans, or how many pieces of metal you had, okay? So speaking about the weight, maybe they didn't have this great necessity to calculate, but they had techniques that allow them to calculate the resistance in the case of architecture, and we will speak about that in the third lesson. Speed of what? they had no animals roaming in the open land, only jaguars in the middle of the jungle. They had no contest of speed. They had they developed the wheel, but they didn't use it that much for trading, but because of the nature of the terrain, so they moved more by the means of canoes, for example. So speed of what? So maybe, yeah, the speed is a concept between the time and the space, and they had a bit more open, a bit more yeah, not so specific or short conception of time. Okay, the conception of time of them was so a bigger one, about the days, about the years. Okay, so the speed is not so clear if they needed to calculate it. Okay, and speaking about the hours, yeah, they had different sections of the day instead of hours, but we will speak about that in the next session, in the session number 2, speaking about astronomy. Okay, so one last view of the Maya numbers, and let's make this activity together. Okay, so in the last let's have 10 minutes more if you want to stay. In these 10 minutes, I will ask your question, but first, let's make this exercise together. Okay, so I will open the chat now, and please participate, guys. And let's focus on the first. Okay, top left figure, top left figure, and you let me know what number is this if you have if you remember the Maya system. Okay, so what number we need here? It is 3 times 400, 3 times 20, and 17 times the number 1. Okay, let me know in the chat what number is this. Okay, so chat is open, you can participate, guys. What number is this in the top left exactly, guys, exactly. 1,277. 100,277. Okay, right. Right. Sorry, my writing has been always awful. Okay, let's focus on, this is easy, right? In the second figure, we have 10 times 8,000, and the rest are 0. What number is this, guys? It is 10 times the number 8,000. So is, remember, it is 10 times. We have the number 5 in the line. 2 lines is the number 10. So yeah, it is 80,000. Okay, that's the number here. And the 0 occupying the empty space. Okay, so let's go now to the bottom left, guys. Okay, what number we have here? What number we need to put here? 400, 5 times exactly, 21 times, and the number 3 with 3 dots in the units. So it's the current year, right? This is the date of the year 2023, exactly. And let's finish one a bit more complex in the last column. Okay, it's a big number, the bottom right. Okay, the number 8,000 12 times, the number 400 9 times, the number 20 19 times, and the number 1 19 times. Okay, who's got it, guys? Michael says 99,999. Exactly. Okay. I mean, it's not always that easy. It's not always that easy, but for you to see how they could do these big numbers. Okay. Sorry again about my writing. Okay, let's just finish this part, and we will begin with the questions and answers. Okay, guys? So this is basically everything for today. I hope you have enjoyed this, in this case, this course, and let's pass to the last part of questions and answers. Okay, remember, if you want to tip, if you want to leave a donation for me to keep continuing doing this, different projects, you can tip here in the link in your screen, or in the first link in the two that we have put there. And at the end of the 4 lessons, we will have a test, a quiz for you. Okay. Thank you so much, guys. And let's start with the questions and answers. Hi, you had a Maya language of Yucatan. Will you have the numbers in Guatemalan Quechua language too? Sorry, no. I found different versions of the Maya language, speaking also about the numbers. Is way different in many cases, but no the Guatemalan Quechua Maya version of the numbers right now. Sorry, Eric. Okay, it was not the okay. Thank you, Jasmine. Thank you, Mr. Rajit, as always, to be here. Mocha, incredibly informative, Fred. Thank you for the presentation and research. Thank you, Mocha Joe. Love it, love it, love it. Thank you, Donna. Love learning about the math system and how storms are predicted like hurricanes. We will speak a bit more about that in the next sessions too. It was a great, enjoyable class. Thank you. Thank you, Farda. Thank you, Bandit Queen. Thank you, Vicky. I'll be watching tomorrow to catch the beginning that I missed today. Thank you, Vicky. Thank you, Leighton. I need a lot more time to solve problems. Wasn't able to solve them very quickly, except one. I mean, you can practice, no? You can practice at home with your born date, for example, a year of the foundation of your country, any other measurement, your age, the age of your relatives. You can practice at home with the Maya numbers. Muchas gracias, Abby. Do you know why the positional system goes from 20 to 400 to 8,000 in that order? Yes, but it has a reason, but we will speak about that reason in the coming lessons. Okay. Thank you, Amanda. It was quick, but I got it. Chemist. I know. 1 hour is much information for 1 hour. Is the link sent out by email? I hope, yeah. This was so informative. Thank you so much. Yeah, let's ask the guys in the organization if the link of the course will also be sent by email. Thank you, Astrid. Thank you, James. This is such an amazing mathematical system. What a beautiful and informative presentation. Thank you, James. This preps for an idea of math club at college. Yeah. Yeah, in some schools they teach one class about this, but it's not like a thing, but the idea of a club sounds great. Will this recording be made available? I think, yeah, right? I think the guys of the organization are online, so they can, but yeah, in this case, the repetitions will be available. The concept of zero is interesting, really interesting, and we will speak more about this here in the coming lessons too. Great class, never heard in context. Thank you, Gwen. Didn't learn this in class, but maybe in higher level ones, maybe. Yeah, the powers of the number 20, of course. Is the link sent? Okay, amazing and great. Thank you. Loved all this information. It really got my brain juices flowing. I know. I mean, it's the intention of these courses, right? Very exciting to retire middle school math teacher, an ancient numerical system with place value. Of course, Teresa. It's amazing we have these old codex. I thought the Spanish destroyed everything, almost everything. These codex are really rare, and because they were well hidden, or in many cases, other codex were made before the conquest. The friars asked the populators to recreate the ancient language and documents. Beautiful codex, right, people? A pleasure learning about space is pretty and seeing the tree changes colors in season is lovely. I mean, it's a beautiful draw, yeah. Are 20 and 0 the same represented by the shell? The first slides you introduced the number system show 20 as the shell. No, the in the slides, maybe you're referring, let's come back. Maybe you are referring to this one. But it's not the 20, it's the 0, right? After 19, start the position system. And the 0 is maybe not in the right or in the best place here, but it's to understand that it's also existed the number 0 here. Okay. Let me read other comments. I'll be reading all your comments here. Amazing and great, thank you. I have a headache very soon. Sorry, it was for so much effort with the numbers. Okay, Rosa, no worries. This one is recorded for us to see. Yes, the one's not academic base, not sent. You have a review to see again. Yeah, you can see this again. The Aztec calendar have so many tools to create it. What are they, Fredo? We will speak about that in the coming session next week. Thank you, Emma. Thank you, Nihim. No worries, Rosa. Looking forward to the next lesson of the course next week. Thank you, guys. You check the calendar. I think it will be the same day at the same time. Just to be sure. Yeah, same day, Thursday, 11:30 in the morning in my time. I don't know. Of course, in your countries can be different, but the same starting time as today. Is there an academic course in a couple of days with a different topic given by Anna? Yeah, many different courses will be given in this season. I went to tour Chichen Itza last year. Very cool learning about that civilization. Thank you, Vicky. Thank you, Mar. Okay, yeah, much information. Looking forward to that one too. Will be completely different than this one. Yeah, really different with more complex calculations. Love learning the ancient Mesoamericans had 0, fed of being told it was invented by the Greeks. They stole it from the Arabs in India. Okay, and India. Actually, the Hindu people were the ones that in that part of the world developed the 0. Thank you, Rosa. I got it right away. Base 2 and base 10 system. Okay. I check same time. Okay, same time next week and same day, Thursday. Root 2 is half-life decay. Interesting that 2 is so important, and other numbers too that we will discover in the coming sessions. Okay, so thank you so much for your attendance, guys. I just want to remind you that you can tip in this first link and in the second one following the program of the courses during September, and during October we will start the course about the Maya gods and the Maya deities. The Mexicans should study this type of math in school. They just mention it quickly, and we make like a couple of activities with that, but not all the kids. Maybe there in the Yucatan region, it's still a bit more important than here in the center of the country. What's the connection between India and Mesoamericans? I mean, the populate of Mesoamerica happens by the migration of the Central Asian civilizations, but more close to Mongolia, Kazakhstan, and all that. So maybe not, at least not in the last 13,000 years. So they got an idea, yeah. Okay, thank you so much, guys, and hope to see you next week for the second part of the course. And greetings, Farida, and to your friends in Kazakhstan. Okay, hope to see you soon, guys. Thank you again for your attendance, and have a beautiful weekend. Goodbye.